Okay, in this video we are going to go over similar problems to group activity 1. So question number 1, in terms of displaying data, how in a stem and leaf plot similar to a dot plot? Just to remind me, the dot plot is the one that you build the dots, right? Based on elements are given in database. Leaves, instead of dots, we are writing by, let's say 1, 2, 3, 7, 8. We are the position of leaves, we are using the numbers in the data, right? And so on. Okay. So, what is the similarity between dot plot and a stem and leaf? So first of all, both show how data are distributed, which makes this one. Version B is correct. First one, both plots can be used to show large amount of data. Absolutely not true. For large amount of data, we are using histogram. C, both plots can be used to determine specific data entries. Yes, because we can see, right, which number, which database, where the element of database, where it's located. And the last one, both plots can be used to identify unusual data values. Absolutely yes. In the case of dot plots, let's say those are dots are located here and one is located here. It's unusual. Or in the case of stem and leaf, let's say 1, 2, 3, we have here some numbers and all of a sudden we have here 10. So absolutely the answer is yes. Okay, question number 2. Use the given minimum and maximum data entry. So we are given minimum and maximum. We need to find the class width. So for the class width, what we are going to do, to find the class width, lower class width, and upper class limit. Okay, so what do we have? We have minimum is 13. Minimum 13, maximum 134. And total we have 8 classes. So how do we identify? We identify class width. We are going to do 134 minus 13, maximum minus minimum, and divided by 8. So 134 minus 13, it's going to be 121, and divided by 8, total 8 classes. Here we have all this information. We are getting 15.1, which means class width, it's 15.125. And here we don't do algebraic rounding, but we do meaningful rounding, which is going to be 16, because we are dealing with existing briefing existence. Let's say if we have 15.1, we don't take portion of life existence. So, and plus the class width, it's a minimum, so you can take one number higher. So if you have 15.0001, so you can still put 16. Now let's see which one it's going to be 16. So we have to take and subtract. In the case of A, right, 44 minus 28 is 16. Now second one, 29 minus 13 is also 16. Okay, let's keep checking. 60 for A, between 28 and 44 is 16. Next, let's see, 61 minus 44 is 17. Okay, so it's a difference, right? Between 28, I'm looking into A. Between 28 and 44, difference is 16. Between 44 and 61, 17. It cannot happen, right? Because class width has to be the same. So 1329 is 16. 45 minus 29 is 16. 61 minus 45 is 16. Well, looks like it's going to be this one. So if you check, 13 and 28 is 15. 28 and 45, it's not 15, right? So it's going to be this one, and the class width, it's going to be obviously 16. So class width has to be the same when you subtract numbers within that given database. Like 29, let's say this one, 29 minus 13, 45 minus 29, 61 minus 45, 77 minus 61, and so on. We will see everywhere 16, and that will be our class width. So now we need to find the correct upper class limit. Okay? Choose the correct upper class limit. So what do we have? If we have 29, right? It's from this case I'm looking. If we have 29 here, then upper class limit going to be by one less here, 28. We have 45, here it will be 44, 61 will be 60, 77 will be 76. So this is going to be our answer. Why I took second one? Let's say we have a low limit 13, 29, 45, 61, and blah, blah. So if it's 29, here it's going to be 28. 45, here it's going to be 44. 61, here it's going to be 60. Okay? That is the reason. Okay, moving to next question. So what do we have here? Using stem and leaf plot display data. So here we have our, let me pick this color. Here we have our database, right? This is all our database. And we need to find all numbers that ends with, start with 2, which stem is 2. And if we look, it's going to be 25 and 29. So here is 25. And where was that? I just saw it. Oh, here it is, 29. That's it. There is nothing else with stem 2. Now with 30, if you look, you will find 33, 35. There are two 35s, right? And then it's going to be 36, 38, 39, 39, two 39s. When it's come to a stem as a 4, we are going to have 40 twice, 40 and 40. And then I'm writing down on the right side, I'm writing down only leaves. But when you read, you connect it. 40, 40. And then it's going to be 41. And then it's going to be 47, 48. And I put in the ascending order. And then about 5, it's going to be 50. About going to be 54. It's going to be 54, 56. And lastly, with 6 stem, it's going to be 60 and 64. If you count this total amount of these leaves, you will get amount of elements in the database. Okay? So the next question is, what can we conclude about the data? So it appears that no employees commute more than 10 weeks. Those are weeks. No, we don't have here 10 weeks because our stem doesn't represent 10. What do we have? It appears for this one, it appears the most employees spend less than 60 hours driving and from work monthly. So 60. So maximum we have 60, right? The most employees Well, here it is, the whole hour. If I provide the line, so it says, with the question, it says that data represent the amount of hours employees at a certain company spend driving to and from work for a given month. What can conclude about data? So minimum 25, maximum 64 hours. So in 60 hours drive to and from company. So this is going to be our answer here. Approximately 20 hours. This is not true because there are some of them 60. D appears that most employees spend more than 40 hours. No, because most employees, this free is much more employees spend 39, almost 40 hours. And it appears there are no employees that drive more than 50 hours. That is not true. There are employees that drive 60 hours. So B is the only one answer. Question number 4. So what do we have here? The number of credit being taken by sample of 13 full-time college students, here it is, 13 full-time college students, are listed below. Find the mean, median, and mode of the data. If possible, measure, if any measure cannot be found or does not represent the center of the data, explain why. Okay, first thing, the mean. To find the mean, what do? Mean is equal. We are adding all data, 7 plus 9 plus 10 plus 10 plus blah, 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 plus 6 plus 7. And since it says there are total 13, so I'm not counting because it's information about 13 students, so we divide by 13, and result you should get 7.2. So the mean is 7.2. Okay, does the mean represent the center of data? So to find out if the mean represents the center of data, we need to rearrange in ascending order. So first we have how many sixes? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many sevens? 3 sevens. 1, 2, 3. And then 1, 8. 1, 9. And 2 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so 7.2, 13. If I take 13, then as a median, what is going to be? 13, so it's going to be the 7th element, right? 1, 2, 3, 4, 5, 6, 7. This is our median. So 1, 2, 3, 4, 5, 6. So median is 7, which means the mean, because there are here on this side all 6, here all the higher numbers, 8, 9, 10, 10, right? So the mean is showing the center, representing our center. So it's going to be this one. Okay, what else do we have? We need to find median. We already found it. Median is 7. All right. Does median represent the center of the data? Yes, because they are equal. Mean is 7.2 and median is 7. Yes, median also represent the center. If it would be different, the difference between them, then not. That wouldn't represent the center. If we would have outliers. Now, here is the thing I want you to know when you do your test or group activity. If you have outliers, so most likely median will be your average, especially when it's come to what? It's when it's come to college students. Median will be the mean, the average. But when there is no outlier, then it's going to be mean and median are going to be very, very close by value. Question number 5. Okay, find the mode, select the correct choice. Okay, when we look to this data we are given, here I have in ascending order. What do you think? Which value represent mode? Mode is the most frequent one, right? It's going to be nothing else but 6. 6 we have the most frequent, so it's going to be 6. Okay, now does the mode or do the modes represent the center of data? Mode in this case does not represent the center, because if one is the smaller, because it is the smallest data value, right? Which is very, very true, because we have, look how higher numbers we have, 7s, 8, 9, 10, so 6 cannot be the average. There are cases when mode will represent the average, but this is not the case. Question number 6. Determine whether the approximate shape, okay, well, this is a histogram, so we need to figure out, is it symmetric, uniform, skewed to the left, skewed to the right? Well, obviously, if I draw the line, it's skewed to the right, correct? So this is what is gonna be the answer. Okay, the next one. The age is of a random sample of shoppers at a gaming store are shown. Determine the range, mean, variance, and standard deviation of the sample data set. Okay, to find the range, we have to get the maximum number. Which one is our max? Maximum number is going to be here 23, right? Range. Max minus minimum, right? Where max is equal 23, minimum is 12, so 11. Okay, the range is 11. Mean, to find mean, do you know how we find mean? You already learned it. So mean is equal 12 plus 19 plus 23 plus blah 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 plus 13 plus 16. How many we have here? Random sample doesn't say, so we need to count then. It doesn't say how many elements are in the database. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 divided by 10, and you should get approximately 16.9. Variance. For variance, you can use some of you can who doesn't like Excel or online calculator can use lecture. You have 3 choices to find variance and standard deviation. You can use lecture. That's the first option. Second option, you can use Excel. I'm not going to do all this Excel and lecture now, because it's going to be a long calculation, and you already know where to find by this group activity. And the third version is look in the comments. You should find a link to the online calculator for variance and standard deviation. And the result for variance, you should get 11.4. And standard deviation, always square root of variance, which is going to be 3.4. Okay, moving to question number 8. Heights of men and baseball team have a bell-shaped distribution with mean, mu, is equal 173 centimeters. Standard deviation is 6 centimeters. Using empirical rule, Find the approximate percentage of the men between the following values. A, we need to find between 100 empirical rule between 161, x is greater or equal 161, less than 185 centimeters. And for B, this is A, and for B, it's 155 centimeters, less equal X, less equal 191 centimeters. Okay, we are going to use empirical rule. So, first case, I'm going to use mu plus minus 1 standard deviation. Then, if it won't match these limits, I'm going to use mu plus minus 2 standard deviation and mu plus minus 3 standard deviation. It should fit one of them. Let me, because this is template for calculation, I put in different colors so you can see. Okay, let's start calculating, see which one it is. So mu is 173. So, okay, let me finish this. This is our 95%, this is our 97%, and this is our 99.7%. Okay, so we have 173 plus 1 standard deviation, which means plus 6 or minus 6. If one limit will not fit, then I don't have any meaning to calculate the other one. So 173 plus 6, that is 179. Okay, I don't have 179 here. I need to have 185, which means this is gonna be wrong. It doesn't match. Next, I'm starting with 2 standard deviation, 173 plus twice standard deviation, which is gonna be 173 plus 12, right? And it's gonna be 185. Bingo. 185. All right. So it's fitting this. Now let's check 173. 173 minus 12, right? 2 times 6, 2 standard deviations. 173 minus 12, it's going to be 161. There we go, it fits. So it is going to be 97%. Okay. And the for the B case, let me change the color. I will use blue color so you can know this is for B. So for A, it is going to be 97%. Okay, now for B, let me see, starting over again, 173 plus 1 standard deviation. Actually, we, let me see, 173 plus 1 standard deviation, 6. It's going to be 179, doesn't fit, right? So we drop this. Next, 173 plus 12, right? Because 2 standard deviation is 2 times 6, standard deviation is 6. So it's, we already have it, 185. It doesn't fit, right? And last one, 173 plus 18, 6 times 3, 3 standard deviation, 18. So 173 plus 18, we are getting 191. Okay, bingo. It fits 191. So this is 191. Now let's check the other limit also. 173 minus 18 is equal 155. So which means the answer here is going to be 99.7. The third one, right? 99.7%. Okay, Next, let's solve this one. Use the accompanying data set to complete the following anchors. First quartile, interquartile, identify outliers. So before we work on this, we need to arrange in the ascending order. Whoever knows Excel, it's easy to write down all this number and put in ascending order. I'm going to do it right here. So the smallest number here looks like it's going to be 54. Next is coming, looks like 56. There are how many? 1, 2, 3. 1, 2, 3. Next, 56, coming 57. Do we have 57? No, only 1, 57. Next, 58. We have 1 and 2, 58. Next is coming 60. We have only 1. Let me write down close there so we can see 58. Hold on, was it 58 or 57? Yeah, 58, okay. 60, so I will do this type of delimitation so we would see it. So it's not 5, 6, but 56. Okay, 60, after that comes 61, only 1, 61. And then comes 62, how many? 1, 2, 3. Wait, 59, we missed 59. Okay, let me squeeze in. 61, 59, 60, 60, and then 61, we have only 1. 62, we have 3. 1, 2, 3, and lastly 77. Okay, how many we have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is this what we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Huh? What did we miss? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's go one more time. 57, here I have. 54, here I have. 58, let me put this way. 57, 54, 58, 56, 60, 58. Bingo. We have two 58s, okay? I put here 58. Okay, marking down. 58. 62. 58. How many 58s? Ah, there we go. Found it. So 3 58s. All right. So 15. Okay. Now, we need to find first quartile. To find first quartile, second quartile, interquartile, first thing we need to find the median, which is second quartile. So if we have total 15, right? So the 8th element is going to be our Q2. 1, 2, 3, 4, 5, 6, 7. So this is going to be our 8th quartile 2. It is going to be 58. Next, let's take a low limit to the left from the Q2, from the median, because this is at the same time also median, right? Q2 is a median. That's why out of 15 I took element number 8. for Q2. Q1, now I need to find the median for the part of database to the left, below Q2. We have 7, so it's going to be the fourth element, right? Let me see. 1, 2, 3. This is going to be the fourth one. This is Q1, which is going to be 56. And also to the right, also going to be the fourth one. Let me see. 1, 2, 3. There we go, the fourth one. This is going to be Q3. $62. Next, we need to find interquartile. So interquartile is equal Q2 minus Q1, which is equal 62 minus 56. It's equal 6. All right. C, identify any outliers. So there is no outliers from what we see. There is no number that is enormously far away from the database. Next, we need to find correct answer. So there exists at least one outlier in the data set. Well, the approximate outlier, I would say this would be this 77. This 77, because it's a little bit far away. I wouldn't say it even much of an outlier, but well, if I look how close the data goes to each other, yeah, between 1 and 2, 1, 1, 1, 1, yeah, and all of a sudden, yeah, indeed, it is outlier. So 77 is going to be our outlier. All right. And the last question, we are going to use Box-and-Whisker plot. So we need to find, first of all, minimum. Our minimum is right here on the Box-and-Whisker plot, writing down 11. Our maximum is right here, 20. Q1 is right here. This is our Q1, which is going to be 14. Q2 is 18. And Q3 is 17. Oh, 16. I'm sorry. I'm seeing 16. And then I was wondering how can the Q3 be greater less than Q2. That's how I caught it. Okay, 16. All right, that's all about group activity, and your test is 2 attempts, and it's very similar to group activity. If you study problems in group activity, there is no way you will fail the test, okay? Okie dokie.